All right, this is part 2 of lesson 211. Consider the line y equals 5x plus 4. Second line is parallel to this line. What do you know about the equation of the second line? Well, if the line is parallel on a coordinate grid, then the slope has to be the same. And the part of the equation that represents the slope is the coefficient. So the slope of the line is 5. So we know the coefficient of the equation is 5. And just as a quick reminder, the coefficient is the number that we multiply by a variable. So that's the coefficient right there. And in the equation, the part that's added to the end is called the constant term. All right. So we want to write an equation for the line parallel to y equals 5x plus 4 that passes through the origin. If it passes through the origin, that means it passes through the point 0, 0, which means the y-intercept is 0, and we know that because if the x value is 0, then the y value is the y-intercept. So we want y equals 5x plus 0. We want the same slope, just a different y-intercept to be parallel. And we can simplify that to y equals 5x. Now, if we want to check that on our calculator, we certainly can do that. Here's my original equation, y equals 5x plus 4. We'll put in the equation y equals 5x, press graph, and make sure they're parallel. They sure look parallel. All right. So I think we're good on that one. Now we want to write an equation for a line parallel to y equals 5x plus 4 that crosses the y-axis at the point 0, 3. Well, since the value of x is 0, the y-intercept is the value of y for that point, which is 3. So we want to change our constant term in our equation that represents the y-intercept on the graph. So we want 5x plus 3. And it doesn't hurt to check that. So we can put that equation in our calculator. 5x plus 3. Press graph. It appears really close, but they are definitely parallel. I want to go to my table or change the window setting on your graph so we can see it better. But I think I'll just go to the table and make sure it goes through the point 0, 3. And we can see that when x is 0, y is 3. So that's good. All right. Okay, and the last question says, write an equation for a line parallel to y equals 5x plus 4 that passes through the point 211. Hint, the data pair 211 must satisfy the equation. What that means is when we have the equation like y equals 5.5x, where if we substitute 2 for x and do 5.5 times 2, we should get the y value to be 11. So we check to see if that's true. Like that. Now I chose the wrong equation, but that's the idea here. So we know that we want to be parallel to this equation, y equals 5x plus 4. And that tells us that at least this part of the equation, the 5x, our coefficient is going to be 5 if it's parallel. So now we just need to come up with a y-intercept that will work for this data pair, 211. In other words, if we substitute 11 for y, multiply 5 times 2, and add the y-intercept, we should get a true statement. So I'll just simplify that. So what I'm saying is 11 equals 10 plus what number? Now we obviously know that number is 1, so b is 1. But if it was a little more difficult to figure out, we could just use some of our equation solving skills here. Subtract 10 from both sides, and we would get b is equal to 1. Now remember, I'm representing the y-intercept using the letter b. So my y-intercept is 1. So y equals 5x plus 1 is the equation, I think, that is parallel to y equals 5x plus 4 and goes through the point 211. Now, we can use our calculator to check that, make sure that works. There's our y equals. Put y equals 5x plus 1 in the calculator. Graph it. It's parallel, we can see that. Let's go to the table and see if that point 211 is there. When x is 2, y is 11. So that's good. All right. Moving on, we have a line. Line has the equation y equals 3x minus 1. Find an equation for the line parallel to it and passing through the point 3, 4. So here again, we want the slope to be the same, which means we need the same coefficient. So we need 3 for our coefficient. We're going to need a different y-intercept, though, to get it to go through the point 3, 4. So I'm just going to represent that y-intercept as b for now. Now, if it goes through the point 3, 4, that means when I put in 3 for x, so do 3 times 3 plus b, and put in 4 for y, it's a true statement. So 4 has to equal 3 times 3 is 9 plus whatever the y-intercept is. Working backwards, I'm going to subtract 9 from both sides, and I get b is equal to negative 5. So I think the equation y equals 3x plus negative 5, or y equals 3x minus 5. And then you can go ahead and check the calculator to make sure it's true. All right, and the last problem, number 6. A line has the equation y equals 4. It says graph the line. So let's go ahead and do that. Graph that line, y equals 4. Clear that, clear that. So y equals 4. Now, if y is 4 and there is no x next to it, that means that the slope value must be such that it makes that x disappear, which means the slope is 0. So just think about what a slope of 0 is as I graph this. So there's y equals 4. Now we want a line that's parallel to that. In other words, we want another horizontal line that goes through the point 3, 6. Well, the point 3, 6 is right, I'll go over 1, 2, 3, up 1, 1, 2, 3, 4, 5, 6. So right there. So I want a line that goes through there. Right there, and it's parallel. Well, that line is going to look a lot like the line that we graphed. It's just that instead of going through the point 4 on the y-axis, it needs to go through the point 6 on the y-axis. So I think that equation will be y equals 6. And there it is. So y equals 6. All right, just by looking at the equations, how can you determine if lines are parallel? They will have the same coefficient. Give 2 examples of 3 lines that would be parallel. If you give examples of 3 lines that would be parallel if you graph them. So make sure that you have the same coefficient when you do that. We'll do that in class. And this vocab will lead us into the next lesson. Blank points all lie in the same line. And that word is collinear. Notice the word line in there. That means all the points are in the same line. So I'm going to start the next lesson there.